So today for lesson 2.3, we're going to be graphing systems of linear inequalities. If you recall, we have graphed linear inequalities on the coordinate plane. And so a system of inequalities is a set of two or more linear inequalities with the same variables. Now our solution set or our solution region was always the shaded area of the inequality. And if it was a solid line, it also included the points on that solid line. Now, since it's a system, our solution region is where the shading of the two inequalities will overlap. So we're going to go ahead and graph these two inequalities you see here in our example. First thing we're going to need to do, though, is to solve them into slope-intercept form or graph them using x and y intercepts. So I'm going to off to the side solve these inequalities into slope-intercept form. So we have x minus 3y is less than 6. We're going to subtract x from each side. Negative 3y is less than negative x plus 6. And then we're going to divide everything by negative 3. Now remember, we divided by a negative, so we are going to have to flip this inequality sign. It becomes y is greater than. That's a negative 1 in front of the x divided by negative 3. That makes that a positive 1/3 x. And then we have positive 6 divided by negative 3 gives us negative 2. So that's our first inequality. We're going to go ahead and graph that starting at negative 2 on the y-axis. And then a slope of 1/3. So we're going to rise 1 and run 3 and continue that pattern. And I'm going to go back in the opposite direction too, so that way I can make sure my shading covers our entire graph where we need it to be. Also, I'm going to go back and look at this inequality. We have y is greater than, so that means I should be using a dashed line because it was not or equal to. And the shading for this inequality is going to be shaded above. And so I'm going to use my highlighter, and you may want a highlighter, and I'm going to go ahead and shade above for that inequality. Now we're only going to do that on this first example. When we get to the next example, we're just going to shade the overlapping region or the region that's a solution to the system. But for now, we're going to see how that works. So we have our second inequality, 2x plus y is greater than 4. We're going to go ahead and subtract 2x from each side. Y is greater than negative 2x plus 4. And we want to graph that now. So we're going to start up 4 on the y-axis. We have a slope of negative 2, so down 2, right 1. And continue that same pattern. Up 2, left 1 also. We are going to go ahead and connect those points with a dashed line since it's just y is greater than. And since it says y is greater than, we're going to go ahead and shade above for this inequality as well. And above would be over here. So now I'm going to go back and really darken the region where our two shadings have overlapped, which is up here on the right, upper right corner of both of these inequalities. And remember, it continues beyond what it shows in our graph. But that dark region I just shaded is now our solution set to our system of inequalities. So now let's look. Are the following points in the system of inequalities? Is 0, 0 in the system of inequalities? And that answer would be no, because it's not in the shaded region, the overlapping shaded region. Is 3, negative 4. So 1, 2, 3, 1, 2, 3, 4. No, that's not in any shading. And the point 3, 4 up here, yes, that is in the overlapping shaded region. So that's how we graph a system of inequalities. So now when we look at the next example, we are only going to shade this darkened region. We're not going to shade for both inequalities. So here's example number 2. 3x minus y is greater than 1, and 2x plus 2y is less than 6. All right, so let's solve our first one into slope-intercept form by subtracting 3x. And negative y is greater than negative 3x plus 1. And then I'm going to divide by -1. Y is less than. Remember, we need to flip that inequality sign because we divided by a negative. Positive 3x and +1 divided by -1 would be -1. So we need to go ahead and graph that inequality starting at -1. The slope of +3, right 1. Down 3, left 1. We're going to use a dashed line since it is just less than. And I'm going to hold off on the shading for this. Okay, let's graph our second inequality here. We have 2x plus 2y is less than or equal to 6. We're going to subtract 2x from each side. We have 2y is less than or equal to -2x plus 6. And then I'm going to divide by 2. And we get y is less than or equal to -2 divided by 2 would be -1x. And then 6 divided by 2 would give me a +3. So I'm going to start up on the y-axis at +3. And I have a slope of -1. So I'm going to go down 1 to the right 1. This does say y is less than or equal to, so I am going to connect these points with a solid line. And now let's determine where the shading should be for this system of inequalities. So the first inequality says y is less than, which means it's going to be all on the right side of that red line. And the second inequality also says y is less than or equal to, which means it's going to be below the orange line. So we need below the red line and below the orange line, which would be this triangle-shaped region here in the middle. Now, if you could name one point as a solution to the system, you could pick any point that's in that shaded gray area. So for example, 2, -2 would be a solution to the system of inequalities. If we were to substitute that point into both inequalities, it would make both inequalities true. All right, let's look at a word problem example now. So Brenda wants to paint no more than 70 plates for the art show. So she doesn't want any more than 70 plates for the art show. It costs her at least $50 plus $2 per item to produce red plates and $3 per item to produce gold plates. She wants to spend no more than $215. Write and graph a system of inequalities that can be used to determine the number of each plate. So first of all, we have red plates and gold plates. It costs her $50 plus $2 per item to produce red plates and $3 per item to produce gold plates. So we have 50 plus $2 per red, so we'll call red X, plus $3 for gold. She wants to spend no more than $215, so that's less than or equal to $215. She also wants to paint no more than 70 plates between red and gold. So between red and gold, or X plus Y, she doesn't want any more than 70 plates, so less than or equal to 70. Those are the two inequalities that then we can solve into slope-intercept form, graph, and find some solutions. So if we start with our first one, I'm going to write it here to the left. We have 50 plus 2x plus 3y is less than or equal to 215. I'm going to subtract 50 from each side first. 2x plus 3y is less than or equal to 215 minus 50. $165. Then we're going to subtract 2x from each side. 3y is less than or equal to -2x plus 165. Then we're going to divide each side by 3. So y is less than or equal to -2/3x plus 165 divided by 3 is 55. That's our first inequality. Our second one, we have x plus y is less than or equal to 70. So when we solve that one for y, we're going to subtract x from each side, and we have y is less than or equal to negative x plus 70. You'll notice that the graph and the scale work nicely with our y-intercepts that we need. Let's graph this first one by starting at approximating where the point 55 is. Then our slope is negative 2/3, so we're going to go down 1, 2, 1, 2, 3 to the right, and continue that pattern. So down 1, which is halfway, 2, 1, 2, 3, 1, 2, 1, 2, 3 would be like that. It is a less than or equal to, so I am going to connect those points with a solid line. Then I'm going to graph this second inequality, y is less than or equal to negative x plus 70. So we're going to start at 70 with a slope of negative 1/1. It's also or equal to, so we will also connect these with a solid line. And then we're going to shade the region that is true for both inequalities. They're both less than or equal to, so it needs to be the area that is below both lines. So a possible solution set here would be 10-10, 20-20, 30-30, 40-20, anything that's within this shaded region. So that is graphing systems of inequalities. There are more examples. I'm going to go ahead and give you a few minutes to work out example 4. And I will write the solution here on the screen. So go ahead and pause the video. See if you can write the inequalities for example 4. Okay, so hopefully you paused the video and now you've attempted to write these inequalities. The first inequality was x plus y is less than or equal to 40 because they can sell no more than a total of 40 hot dogs and sausages. Second inequality comes from the sales here. Hot dogs sell for $2 and sausages sell for $2.50. They need to make at least $90, so that's why it's greater than or equal to 90. So again, pause this video, solve them into slope-intercept form, and then we'll go ahead and create the graph. Okay, and you can see here I'm solving each inequality into slope-intercept form. I am doing 2 divided by 2.5 to get 0.8, or 8/10, which then we could reduce, plus 90 divided by 2.5 will give us 36. And I'm going to go ahead and reduce that slope to 4/5x plus 36. All right, so let's graph these two inequalities. Y is less than or equal to negative x plus 40. Start at 40. Slope of -1. With a solid line because it's less than or equal to. Then I'm going to graph my second one here. So y is greater than or equal to 4/5x plus 36. So we need to approximate where 36 is. 2, 3, 4. Again, connect with a solid line. And then go ahead and shade the overlap. And hopefully you picked up on the mistake that I made here when I was graphing this blue line, is the fact that I forgot there was a negative in front of this slope here, because my negative sign came kind of small here. So our slope is actually -4/5. So we start at 36 and then we're going to go down 4. So 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 5. Connect that with a solid line. There we go. And we need to shade above one and below the other. So we actually have a very teeny area that we would shade here, which is right here. So that is graphing systems of inequalities. We are graphing both inequalities, shading the area that makes both inequalities true, and then our solution set lies within the shaded region for both inequalities. So there are more examples that you are going to practice. You can always let me know if you have any questions. Feel free to ask each other, and I hope you have a great day.